Now let's go to the next loop, that is the for loop. The for loop is also an iteration statement. It is an iteration statements which is same as the while loop and do while loop, except you don't have to specifically separately initialize the loop control variable. Here the loop control variable and the incrementing or decrementing the loop control variable is part of the syntax itself. So first let us understand the syntax. For, here initialization, semicolon, condition, semicolon, and then step. I am writing it as step. Step can be either incremental manner or it can be decremental step. Inside the flower brackets opening end is the set of statements. So now students, here you don't have to write I++ or I minus minus. You don't have to do all those things. Everything will be taken care in the syntax itself, that is the header of the loop, that is the for loop. Let's take an example to better understand. The flowchart for loop is same as the while loop. That's the reason I'm not going to redraw it once again. You can just give the same flowchart for the for loop also. Hash include stdio.h void main, then declare the variables n, p, I, semicolon, accept the input, enter n, scanf, %d ampersand n. I'll write it on this part of the board. For I is equal to 1, I less than or equal to 10, I plus plus. I hope now you have understood what I meant while explaining the syntax. Here only thing you have to write is p is equal to n into I, printf %d into %d is equal to %d n comma I comma p. Close the flower bracket of the for loop and close the flower bracket of the main function. So now what we have done is we have implemented the same program or the same example using all the different kinds of loop, and now after learning all the three kinds of loop, I think now you have felt or understood that for loop seems to be much better compared to other two loops. Yes students, generally when we are working with array or matrices, two-dimensional matrices, we go for the for loop, not the while and the do while, because here it's easy to write the code and manage. Students, now I will explain to you how exactly the for loop works by writing something like algorithm, like steps. So step 1, initialization. Step 2, the condition will be checked. Checked. If it is true, entry to the loop. Otherwise, step dash, I will write the step later, that is step 3, execution of loop statement, execution of statements. Step 4, increment or decrement loop variable, which is called as loop control variable. Step 5, go to step number 2 just to check whether the condition is true. If true, repeat it. Step 6, exit from loop. So here I have to write step 6. I can also write if true, go to step 3, but it's okay. Whatever I have written is more than enough. Students, this kind of explanation you will not find it in most of the textbooks. So in the class we try to explain to you the concepts in most simplest form, so that as a beginner you are able to understand the fundamentals of programming language. Now that we have understood the different types of loop, we take one more example. The program to generate factorial of a number, or to compute factorial of a number using the for loop. What do you mean by factorial of a number? You have already studied in your school days. So if I have 4 factorial, 4 into 3 into 2 into 1. So that is 2 1s are 2, 2 3s are 6, 6 4s are 24. So that is 4 factorial value is 24. Now we need to solve this problem. Students, whenever you are going to solve the problem using C programming language or any programming language, first you need to understand how to build the logic. Let's see how to solve this problem. Your observation matters a lot. See, first you have to observe the numbers or how you are solving this. Very first observation you need to do is, you can see that the number is decrementing, or if you are seeing from this side, the number is incrementing and it is starting from 1 and going up to n. So now you come to know that I can be considered as a loop iteration variable, and it starts from 1 and goes up to n, that is exactly up to n. And every time there is a multiplication happening, so which means that there is multiplication between the numbers. What I will do is, I'll just say fact as 1. I'll initialize a variable called fact as 1. Why? I will tell you now. So very first number I generated, that is 1. Factorial of 1 is 1. So I got the answer 1. Why? Because the fact value is 1. 1 into 1 is equal to 1. Now I am going to assign this to fact. The latest answer what I got, I am going to assign this to fact. So I can write it like this. For this, fact is equal to fact into I. Isn't it? Next, I am going to take the second number 2 and multiply again by fact. What is the last value of fact? 1. 2 into 1 is 2. Now fact value is 2. Next number is generated, that is 3. 3 is again multiplied by fact. 3 into fact. Fact value is 2. Answer is 6. 6 will be assigned to fact as per this instruction. The next number is 4. 4 into fact. What is the value of fact? 6. 6 4s are 24. This is assigned to fact, and we are done with generation of all the numbers, and we got the result 24. This is how you need to build the logic. So this program is very simple. It only contains one for loop, one initialization of the result, and one statement to compute the factorial. Let's write the program. This is how we need to learn programming. The more you practice, the more you understand. Don't by heart the programs. The programs are, or the problems are never meant to be by hearted. You have to build the program logic on your own, not by hearting. Void main hash include stdio.h void main. Now I'll declare the variables. I have to declare loop control variable I, and then n, that is the input, and fact. I'm going to assign it 1 here itself to show you that we can do the assignment in the declaration itself. Accept the input, printf, enter n, scanf, %d ampersand n. I'm using only integers as data type because all the program requires only integer output. Now I accepted it. I write it on this side of the board. For I equal to 1, remember we have to start from 1. I goes up to n, not e. Yes, sorry. I goes up to n. So I less than or equal to n I plus plus p, or sorry, fact is equal to fact into I printf. You can do the printf later. Done computing the factorial, printf factorial of %d is equal to %d slash n. Here you have to write, I'll write it over here, fact, first one is n comma fact, close the flower brackets, sorry, close the round brackets, close the flower brackets for the main function. So very easily we solve the problem of factorial. Students, I want you to solve the same problem of factorial using while as well as do while. Now that we have understood all the different kinds of loops, there is one more concept that is called as nesting of loops. I am sure that now you are very much familiar with the word nesting because we have learned it in switch, you have learned it in if. Nesting means putting one inside another. So if we have a loop in another loop, then we call it as nesting. One loop inside another loop is called as nesting. A loop inside another loop. Okay? One thing you need to remember, always in the inner loop finish or executes all the iteration for one iteration of outer loop, which means for every one iteration of one repetition of outer loop, the inner loop will finish its execution completely. It finishes repeating n number of times and then goes to the next iteration of the outer loop. That's what I meant. Let's take an example over here. A representation for initialization, condition, and then step. Okay, here if you have one more loop for initialization, condition, and step. So this is called as inner loop. Obviously this will be the outer loop. So one iteration, one entry to the body of the loop, outer loop, then it completes all the executions or all the repetitions and then goes to the next iteration. It is like this. Okay. Take for example, for I is equal to 1, I less than or equal to n, I plus plus. For j is equal to 1, j less than or equal to m, j plus plus. Okay. Assume that n is having the value 3 and m is having the value 4. So outer loop will be executed 3 times, inner loop will be executed 4 times. So total number of iterations eshtayitu? Very easy. The mathematics is n into m. So that is 12 iterations. Total iterations will be 12. We'll take some examples. Students, I have written some stars in such a manner that there are first row contains 3 stars, second row also contains 3 stars, third row also contains 3 stars. So there are 3 rows. Okay. Now we need to generate something like this. For that, I just only write the code block. For I goes from 1, I less than or equal to 3, I plus plus. Why? Because we want 3 stars. Then for j is equal to 1, j less than or equal to 3, j plus plus. Printf, I want to display star. Here I will only write star. Okay. And I have to write one printf here. After each line, go to the next line. After printing each stars of the first line, go to the next line. If you don't write this, all the 9 stars will be on the same line itself. How does this work? See students, the very first I value is 1. Is I less than 3, 1 less than 3? Yes, it is true. 1 less than 3 is true. So it will go into the for loop or the outer for loop body. Here there is one more for loop and j value is 1 now. Is j less than 3? Yes. Then it will go to the printf. So what it will do is it will print 1 star and then increment j plus plus. J now will become 2. Is 2 less than or equal to 3? Yes. Print once again 1 more star. Now j plus plus will be done. J less than, j now is 3. J less than or equal to 3? Yes, it's true. Print 1 more star and then j plus plus. J is now 4. Is 4 less than or equal to 3? No, it comes out. Now I value is 2 because we have successfully executed this part. Printf, go to the next line. This printf slash n brings the cursor to the next line. Now I value will be incremented for the outer loop. Please understand it carefully. Now we have completed the first iteration. Now we have to go for the second iteration, I plus plus. Again it will go, j is first initialized as 1. Is j 1 less than 3? Yes. Print star. J will be now 2. Is j? Yes. 2 is less than 3. Increment it. 3 is less than or equal to 3. Yes. True. Now it will come 4. 4 is less than or equal to 3. No. Then exit from the inner. Come here. Go bring the cursor to the next line and increment the outer loop. Now I is equal to 3. Again, is 3 less than or equal to 3? Yes. Go to the loop. J will be initialized. It will print all the 3 stars exactly like the previous iterations. Printf brings the cursor to the next line. Increments I value is 4. Is 4 less than or equal to 3? No. So it will not continue. It will exit from the body of the loop. So this is what the working of this nesting of loops. Students, similarly you can have nesting of while loop as well as do while loop. I'll take one more example. The next example what I want to discuss is, I want the pattern of star to be exactly like this as the output. The first line 1 star, second line 2 star, third line 3 stars. In the previous example all the stars were equal, but now it is in like something like a triangle kind of format. How to do this? First line 1 star. When the first iteration goes, the second inner loop also should execute only once. When the outer loop second iteration goes, I value will be 2, inner loop also should execute only 2 times. Similarly, when the outer loop initializes the value as 3, increments the value as 3, the inner loop has to run up to 3. So it has to run up to 3. That is the key word over here. Only changes you have to do over here. Instead of 3, it depends on the outer loop. So I you have to write. So how does this execute? We'll see. So very first, I value is 1. Is 1 less than or equal to 3? Yes, it's true. Go to the loop. J is 1. J is 1 less than or equal to 1? Yes, it's true. Print 1 star. Go to the next line. Increment the I. Now I is 2. Is J value is again 1. Is 1 less than or equal to 2? Yes, it's true. Print 1 star. Then again go. Increment J. Is 2 less than or equal to 2? Yes, it's true. Print 1 more star. Increment J. J is now 3. Is 3 less than or equal to 2? No. Stop. Stop means come out of this loop. Execute the printf. Go to the next line. Alright. So I value will be incremented to 3. Again this repeats. Now here instead of 2 the value will be 3. This process repeats. Here it will print 3 stars and then brings the cursor to the next line. I value incremented to 4. Is 4 less than or equal to 3? No. It comes out of the loop and stops. And we got this pattern. I hope you have understood. Very easy, right? Okay. Now I want to take one more example. Now we want the pattern to be in the opposite of what we discussed earlier. First row I want 3 stars, second row I want 2 stars, then I want the 1 star. How to solve this? Students, what changes you have to do for this is, you have to start the variable from 3 and goes up to 1. Why? Because you are going in a decrementing manner, 5, 3, 2, 1. So I am starting with 3 and going up to 1. So here I am putting the greater than or equal to symbol. Why? Because since you are doing reverse of the incremental process, here also you have to change the relational symbol from less than to greater than. If you put less than, then loop will not execute properly. When you do ulta, that is reverse order, even here also you need to do the decrement operator instead of increment operator. Only change what I did was this itself. Rest of the program remains same. So I equal to 3, j equal to 1. Is 1 less than or equal to 3? Yes, it's true. Go and print 3 stars and go to the next. Now I will become 2 because I minus minus. This 2 will be substituted here. 2 stars will be printed. Similarly, this loop will execute up to here. Students, in this video I explained to you the decision making and looping statements, and I also explained to you the nesting of looping statement with appropriate statements. I want to give you some assignments over here. I want the pattern to be like this. Instead of star, I want the pattern to be like this. Okay, so 1, 2, 3 instead of star. Please try to implement this and try to print in this way. Also, it's like 1 in the exactly equilateral triangle format. Okay, I want the output to be like this. Try working on such kind of problems. If you are working on such kind of problems, then working with looping will become very, very handy. Students, in this session we learned quite a lot of things. We learned decision making and looping. In that we learned for loop, while, do while, as well as nesting of loop. We solved a lot of problems as well. Please watch the video till the end for the practical implementation of the problems which we have discussed. Thank you. Happy learning. Now let us implement the looping statements. First I'll explain to you the while loop. This program generates the multiplication table for the input integer. I'll compile the program. Let me run. I'll give the input as 5. I got the 5's table as output. The same program now I will show you in do while, as discussed in the video lecture. Here I have to make the changes. Write the keyword do. The same program modified now as do while. I'll compile it once again. Now I'll execute it. As 4, I got the 4's table. Now just to show you the difference between while and do while, see, I will give the input as 11 now. Our intention is to generate multiplication table for the number, right? So it has to be like 5 ones and it has to go up to 5 tens. That's what we have written in the condition. So the loop has to execute 10 times. But here intentionally we have given I value as 11. So even though the condition mentioned in the while fails, but still the loop will run at least once. I compiled it. Now I will run. I'll give input as 6. It should run at least once. Output as 6 11s are. Yes, we got the output. So I hope now you have understood the difference between while and do while. If the condition fails, still the loop block will execute at least one. The same I will do it for while and show you. I'll copy this. Okay. Now I am showing the same example for while loop to test whether the loop will give the same output as do while loop. I'll compile it. Now I will run. I'll give the value 7. I should not get any output. Yes, I did not get any output. Now the same example will be transformed for loop. I will delete all this. For I equal to 1, I less than or equal to 10, I plus plus. Okay. So in for, no need to increment in the body of the loop control variable. The program is now ready. I'll compile it. I'll run it. I'll give the value as 10 now. I got 10 stable. Okay. Suppose I don't write anything over here. The initialization is not there, condition is not there, as well as incrementation is also not there. What will happen? We'll see. I'll give some value as I value as 1. I'll give the input as 4. What's happening? This execution will continue, in the sense the program will keep on executing and it will never stop. Why? Because now there is no stopping condition. So if you want to have an infinite loop, andre, if you want the statements in the body of the loop to be repeated infinite number of times, then you can use something like this. It is same applicable for while loop also. While 1 is always true, I'll execute. I'll give the input as 2. Now you can see that the loop is continuously executing. It will never stop. I have to forcefully close it. Now I'll give the value 0 as condition. I'll give 2 as input. I did not get any output. So as mentioned, the loop will execute only when the condition is true. Students, now you came to know how to run the loop infinitely also. And you also came to know that in the for loop, the initialization, condition and step is also not required. I'll show you one more variety now. I equal to 1, comma j equal to 1, I less than or equal to 10, I plus plus, comma j plus plus. I'll save, I'll compile, I'll give a number as 5. See here, now we are able to get the value of I 10 times incremented, j also incremented 10 times. The loop has executed 10 times. What did you understand from this? You understood that you can double initialize variables over here, double increment also the variables over here. You can go for one more also, it doesn't matter, but here you cannot use comma operator and say j less than or equal to 10. Why? Because the condition, this is not permitted. There should be only one condition, there cannot be two conditions. Now I will show you the program to compute the factorial of a number. I'll modify the same program. I have to declare n fact as 1 as I mentioned, and then one variable for loop. The same thing holds good. I can use the same input statements. I equal to 1, I less than or equal to n, I plus plus, fact is equal to fact star I. I'll display the output after the for loop, because after computation we have to display factorial of percentage d is equal to percentage d, here n and here fact. I'll save it, I'll compile it. Control S is the shortcut key for saving. Now I'll execute it. I'll give the number 4 because that's the example I took in the video lecture class. I got the answer 24. I can give 5 also. I got the correct answer. So you can try giving various inputs. Now I will show you the problem of printing the pattern using nested for loops. /n is used to bring the cursor to the next row after printing the first row stars. I have to declare variables now, m and n. So I'll just avoid the inputs. I will assign the values for n and m. I'll declare all the variables. Remove this statement also. Okay, I think I am done now. Yes, I got the pattern. Now I'll modify this to get a triangular kind of pattern. See here. Now I'll display the pattern in another form. Okay. So these are the programs which we discussed. I want you to practice even more programs. Thank you.